guys, welcome back. Today is Tuesday, March 31st, and we're here today to focus on lesson 12.1, which is fractions and decimals. The main thing that I want you guys to understand today is that a decimal is simply another way to represent a fraction, and they have an extremely close relationship. And that is really essentially the goal for today's math lesson. So let's take a look at this place value chart. If we were going to represent one whole, we would just write it as a 1 in the ones column. If we were going to represent 10, the number 10, right, it would look like that. And if we were going to put it in as a fraction, we would do it 10 over 1, right? That would be the whole number 10. A whole number 1 as a fraction would simply be a 1 over a 1. And we know that any number that is where your numerator and denominator are the same, it is always equal to 1. The same thing holds true for fractions that represent decimals. So if this right here is 1/10 of something, it's a part of a whole, right? And this is shown as a decimal, 0.1. I can also read it as 1/10, just like the fraction part. If we move over to 1 over 100, we would say 1/100th. And the same thing with a decimal. It would look like this, where our 1 would be in the hundredths column, and we would read this 1/100th as well. Over here in the thousandths, 1 over 1,000 would look like that as a fraction, and when you're talking about a decimal, it would look like this, 1/1000th. Okay. So fractions and decimals can be used to show relationships between numbers. And I want to take a look at this problem here. According to a survey, 7 out of 10 pet owners have a dog. 7 out of 10. We've learned that when we say 7 out of 10, we learned previously in our fraction unit that would look like that, 7/10. So how many pet owners actually have a dog? Well, 7. And now we're going to write that as a fraction. So I could say 7 over 10, or I could write it like that, 7/10. Now let's write this as a decimal. So 7/10 as a fraction looks like that. And if I'm going to write it as a decimal, I would write it like this, 7/10. Now over here, I have 10/10, which make a whole. And if I wanted to shade in 7 of them to represent 7/10, I could do that. 1, 2, 3, 4, 5, 6, and 7. So this shows 7/10 as a model. So how many pet owners do not have a dog? Well, if 7 out of 10 do have a dog, then how many do not? 1, 2, 3. And if I wanted to show that as a fraction, I could say 3/10. And if I wanted to show that as a decimal, I could say 0.3, 3/10. If I want, I can put a 0 placeholder after that. So each pet owner is equal to what fraction? Well, each pet owner, right, is 1/10. And each pet owner is equal to what decimal? Well, that would be the same, 1/10, which would look like that. All right. Now I want to just show you something here, and we're going to talk more about this concept. But I wanted to show you that 7/10 is equal to 70/100ths. So I'm going to write that up here. 7/10 is equal to 70/100ths. And I like to do a little trick that works out really well. If I look here and I cross off those 2 zeros, what do I have left? 7/10. Look at that. So 7/10 is equal to 70/100ths. And here's why that works. If instead of these being broken up into just tenths, if I had this as a hundreds grid, right, and it was broken up by all these little squares like that, I would still have the same amount of green, but now if I counted all the little squares, right? I would count 70 of them. So this would be 70 out of 100, and that's why it works. All right, let's take a look at Cherry Street. On Cherry Street, 6 out of 10 houses have swing sets in their backyards. How nice for those little kids. All right, so 6 out of 10. So how many houses have a swing set in their backyard? Well, we have 6 of them, right? And if I was going to write that as a fraction, I could write it as 6/10, 6 out of 10. And if I was going to write it as a decimal, I could write it like this, 6/10. And let's show that on our model. Well, there's 10 houses here, and if I have 6 of them, it would look like this. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. Just double checking my work. And then I could shade all of that in a lot nicer. So if 6/10 have swing sets in their backyard, how many do not have a swing set in their backyard? So we can either count 1, 2, 3, 4, and write this as a fraction, 4/10, and write this as a decimal, 4/10. Excellent. Now let's take a look at Apple Street. These are nice names of streets, don't you think? On Apple Street, 60 out of 100 houses have swing sets in their backyards. Wow, 60 out of 100. Would the decimal models be the same or different for Apple Street and Cherry Street? Remember, Cherry Street was up here where we had 6 out of 10 houses, and Apple Street is 60 out of 100 houses. So let's think about that. 60 out of 100, right, would look like this. So I'd have 10, 20, 30, 40, 50, 60. All of that, right? That's what it would look like. And if I had, this was Cherry Street, I had 6 out of 10, or 6/10. 1, 2, 3, 4, 5, 6. And if I stand back and kind of look at those two models, I see that the same amounts are shaded in. So 60/100ths is equivalent to 6/10. Or I could say 60/100ths, 60/100ths is equivalent to 6/10. And oh, I'm so sorry you weren't seeing that. And the cool thing about this, and where I'm pointing to right now, is that all we would have to do would be to add a placeholder 0 for these two to look identical, right? This we would read as 60/100ths, and this one without the 0 we would read as 6/10. But if I wanted to add that 0, I can, and of course if I want to add zeros in front, I am welcome to do that as well. And I do like my little trick of crossing off those zeros, and it's just a visual that lets you see that these two are equivalent fractions indeed. All right, our last problem of the day. We're doing a quick one today, and we're going to get started on our Pearson Realize work. The last problem involves money. And whenever we're talking about decimals and money, we're going to talk about dimes and pennies. Now, we know that a dime is worth 10 cents, right? 0.10. And 1 penny is worth 1 cent, right? And we represent that as 1/100th, because a penny, $1 is 100 pennies, right? And we can say for this, for 10 cents, we have 1/10, or we could say 10/100ths if we're talking about $1. So let's see, how much money do we have here? We have 1, 2, 3 dimes, so that'd be 30 cents. And we have 2 pennies, so we have 32. And we can write that as a fraction, 32 hundredths, because again, there are 100 cents in a dollar. Or we could write it as a decimal. We could write 0.32, 32 hundredths. It's as simple as that. All right, guys, I hope that you got the essential understanding out of this lesson. We're just wanting you to understand that a decimal is simply another way to represent a fraction. They go hand in hand. They both talk about parts of a whole, and we're going to be doing a lot of practice work on this, so it will solidify in your head. And as always, if you have questions for Mrs. Atkinson, please don't hesitate to reach out. Join our Zoom meetings. I stay after for office hours after my last caller, and it gives you a great forum to see me face to face and be able to answer or ask any questions that you might have. Until next time, I will see you guys soon. Have an awesome day.